This series of flashcards is about pH, a concentration scale for acids and bases. Let us now find the pH of a solution with a hydronium ion concentration of 1 × 10 to the minus 10 moles per liter. This is a very low hydronium ion concentration. So if you predict that the pH would be high and the solution basic, you would be correct. Let's do the calculation on the next slide. Now let's find the pH of our solution that has a hydronium ion concentration of 1.0 × 10 to the minus 10 moles per liter. Again, we'll take the negative base 10 logarithm of the concentration. Once again, the log of 1 is 0. The log of 10 to the minus 10 is minus 10. So the sum of those is 10.00, and the solution is indeed basic. Let's find the pH of a solution that has a hydronium ion concentration of 1.6 × 10 to the minus 3 moles per liter. We know the pH is going to be somewhere around 3, which means the solution is going to be acidic, but what is the exact pH? Let's do the calculation on the next slide. What's the pH when the hydronium ion concentration is 1.6 × 10 to the minus 3 moles per liter? Again, we'll take the negative of the base 10 logarithm of the concentration. The log of 1.6 is 0.20. The log of 10 to the minus 3 is minus 3. The sum of those two is minus 2.8, and so the negative of that gives us the pH of 2.8, and the solution is indeed acidic. As an aside, it's worthwhile to comment on the logarithm of 1.6. Remember that base 10 logarithms are the power to which you must raise 10 to get a number. What power do we have to raise 10 to get 1.6? That power turns out to be 0.2. 1.6 is not a large number, so the power to which we must raise 10 is not a large number, and so 0.2 is an entirely reasonable result. In previous slides, you've seen how to find the pH from the hydronium ion concentration. But how do we go the other way? How do we go from the pH to the hydronium ion concentration? Recall again that the pH is the negative of the base 10 log of the hydronium ion concentration. We can write that another way. The logarithm of the hydronium ion concentration is equal to minus the pH. If we take the anti-log of both sides, we find that the hydronium ion concentration is equal to 10 to the minus pH power. What is the hydronium ion concentration of a solution with a pH of 5.0? Remember that the hydronium ion concentration is 10 to the minus pH power. So here it's equal to 10 to the minus 5 power. And so the hydronium ion concentration is 1.0 times 10 to the minus 5 moles per liter. What is the pH of a dilute hydrochloric acid solution with a concentration of 3.0 times 10 to the minus 2 moles per liter? Here we have 4 possible answers. 0.030, number 2, 1.52, number 3, 1.92, number 4, 2.48. Let's look at each of these 4 answers before we do the calculation. We're taking the negative log of 3.0 times 10 to the minus 2. So we know that the answer is going to be something less than 2. In the previous slide, we asked to find the pH of a solution whose hydronium ion concentration was 3.0 times 10 to the minus 2 moles per liter. If we take the negative of the base 10 logarithm of this concentration, we find 1.52 as the pH. This corresponds to answer number 2 on our list of possible answers. Let's return to the illustration from your textbook of various solutions and their pHs. Vinegar has a pH of 2.8, a hydronium ion concentration of 1.6 times 10 to the minus 3 moles per liter. An orange has a pH of 3.8. That's 1 unit higher in pH than vinegar. Therefore, its hydronium ion concentration is a power of 10 smaller than the vinegar hydronium ion concentration. Blood has a pH of 7.4, very close to neutral. a hydronium ion concentration of 4 times 10 to the minus 8. Ammonia, as you well know, is quite basic. It has a pH of 11 and a hydronium ion concentration of 1 times 10 to the minus 11.